Welcome to our session here. We're talking today about a modern architecture for adopting reactive applications. My name is Javin Sword, and I'm here with Tito Rahman, and we're from Wells Fargo. So let me talk a little bit about what we have to speak with you today. Our agenda will be, we'll do a quick welcome and introduction of ourselves, talk with you about a need for a new approach for monoliths, challenging the challenges that we've had and our solutions approaches, that we go about dissecting the problem space using domain-driven design, taking those domain-driven design artifacts and mapping them into the architecture and implementation. And we've got a really nice demo for you today to show you how we're turning some of our monoliths to microservices using reactive approaches. And Tito will have a demo. And finally, we'll wrap it up with all the lessons that we've learned over the time. My name is Javin Sword. I'm a vice president and systems architect at Wells Fargo. I work in enterprise architecture. I lead the application hosting architecture for the firm, primarily focused on the Cloud Foundries and the Kubernetes PaaS environments.
Good morning and good afternoon, everyone, depending on where you are. I am Tito Rahman from Wells Fargo. I lead the application modernization framework and methodologies, modern application architecture, and case management.
And for more information about Wells Fargo and our success story, what's driving some of this work and this transformation, there's some links in the slides that'll be provided that you can get to see our success strategy, our current transition to public cloud services, and our Wells Fargo technology strategy. So first, I want to start out with saying about the complexity of a bank our size. You know, we are a large financial services environment. We have an extremely large heterogeneous environment with mainframe, mid-range, distributed, and cloud native. It's very typical of a financial services institution. We have many integration points and integration systems in the mix. We have various layers of architecture that need to be consolidated. So about this, we really need to start with our process. So to do this, we incorporated recently domain-driven and event-driven design into easy to follow guidance for our application teams that are on the ground. And we're delivering this through a set of conventions through code. We want to make the most out of these composable microservices and reactive communication techniques. So we're tackling kite coupling directly in the existing monolithic systems. So as to accelerate our cloud native transformation, we want to drive toward a framework that can help accelerate 80% of the necessary communication patterns for a large enterprise such as us. We want to create easy to describe prescription by convention, and so that we can reduce systems complexity for our 30,000 plus developers. Our goal, right, and engineers, our goals will be to use a combination of these tools, techniques, and practices to accelerate our progress toward modern reactive systems, shift our practice left by codifying that design space, develop practices that are easy to adopt for a very large development audience, and ensure that all framework that we write is code, right? So that we can verify that code for architecture fitness and run fitness functions and target ephemeral and cloud native environments while we allow for techniques that help to strangle the monolith. So for the rest of the demonstration, I'm going to turn this over to Tito, excellent engineer. Tito, why don't you start us out with challenges and solution approach?
Thanks, Javin. Today, I'm going to walk you through the approach we took for modern architecture-based reactive application, our journey and lesson learned. So we're going to do a quick sample application demo to showcase our approach. We are in the process of making this sample code public and open source. Hopefully, our experience will benefit others. Let's start with the challenges from CIO, strategy, and delivery point of view. Like many of you, we used microservices and event-driven architecture industry trend for building application as suites of services. We all know reactive microservices comes with complexity around transactions, interactions, development, elasticity, and resiliency. As you can see, the landscape is quite large. So we bucketed the landscape into infrastructure and boilerplate coding, separating from business logic in a configurable manner with right level of abstraction so that the developer can focus on business need implementation. The approach enabled us the outcome of modern architecture, cloud, time to market, along with jumpstart the development. So next, how do we dissect the problem space? As Javin mentioned earlier, our choice was domain-driven design. So through the fine-tuning based upon iteration of practices, this is the high-level domain-driven design process flow we used to produce various DDD artifacts. Since our project is in brownfield, we already had all the business information captured with most of the artifacts as input. Using event-first approach, we did the event modeling and captured events, commands, query, API request response, flow, roles, and interactions. Our team was more comfortable using activity diagrams because of the familiarity. So we created our own template using enterprise architecture Sparks. However, you can certainly use event modeling practices like the one prescribed by onode.com team. So using the flow, we produce all the DDD artifacts that describes the state change of the system, customer journey, read models, events, and many more. So our goal is to have the transition of the DDD process, event storming and event modeling, to tactical design and implementation seamless. So we wanted our framework to support the intake of these DDD artifacts. Let's do a little more deep dive in our DDD artifact mapping, design, and implementation. So continuation from the previous slide. So I'm going to describe the mapping in bit detail. So we choose open source exon framework, which we found covers most of the ground of the boilerplate code. So we extended it with supporting additional challenges that we bucketed or tagged as boilerplate code. You can choose any framework you like, as long as it covers the landscape of boilerplate coding, which you must solve no matter what tool you use. We defined our domain in a domain model project to describe our business domain matching our business language. Next, we define our contract for state change of the system and notifications. So we are using CQRS. So that means these are our commands and events. So this is our microservice Spring Boot project backed by our microservice framework. So the project structure, if you notice, is influenced by Microsoft eShop Container Reference Application. As for the mapping, notice DDD artifact commands mapped directly in architecture and in implementation. Same for event, query, aggregates, and rest of them. So this mapping shows how our framework takes DDD artifacts as input and makes business need transition smooth, and developer does not have to worry about anything related to boilerplate coding, tools, and communications. Finally, we also wanted to have a guided implementation so that we can utilize less experienced existing resources as well. So introduce some repeatable coding practices, writing controller, command handler, event handler, and Saga. So monolith to microservices, our approach. So we used a strangler pattern using parallel run as usual, right? Run with a bit twist. I'll use our sample app to explain. So we broke the functionality into core microservices in blue and identified supporting microservices in orange. Then we added our infrastructure services in gray and UI in red. So our requirement was to minimize the impact to the legacy system. So we moved our users to the new UI, use the new functionality, and redirect to the legacy system for the functionality that has not been migrated. Let me quickly explain the messages. What is command? So do something, intend to change the state of the system or trigger the side effect, maybe 0 or more events. And event is a notification that something relevant happened. And finally, the query is need for information or state, basically your read model. So both command and events use a separate bus and it is distributed. Excuse me. So we are using CQRS with event sourcing. So command emits events, then event get inserted into event store so that we have single version of the truth. Event get published to event bus for others to consume. And external system like case management, events get transformed to the domain events. Notice the change of the color. Finally, we use the anti-corruption layer to create the same process in legacy system to keep things in sync. So we used BPM event emitter for any legacy system changes sync back to our modern application. The key point is over here, commands are decoupled using distributed command bus. When you are making change of the system, events are using Kafka or distributed event bus. The outcome, we are able to respond quickly to the market changes and emerging opportunities with digitally enabled business solutions. For today's demo, I am using React UI, Spring Boot, Apache Camel, Kafka, and MongoDB as event store. Since I'm representing was Fargo, so I'm going to use Know Your Customer, one of the business cases that we have. So it's a very simple due diligence flow, which involves several steps of data gathering, various policy checks, and an approval process to make the decision whether we're legally allowed to do business with the party. So in our sample app, you will notice how we broke down the functionality into microservices, which are designed to operate independently. In our demo, we used Saga to handle KYC initiation request among microservices. We used 4 independent case definition using JBPM case management to drive the KYC process. Okay, let's start with the demo. So I'm using video for the sake of the time, but I should be able to show you if any questions are there live as well. Let me switch back to video. Okay. All right, so I'm going to use Kiali to show the live view of architecture on the wire of our system in this demo. So let's zoom in to see the services over here. So as you can notice, we have a party service which maintains the party and manages that. And then we have approval service. Similarly, we have KYC, Know Your Customer service. And then we have event publication. This is the supporting services, case management wrapper, and other supporting services, scanning services, and event publication service as well. So next we have for the tracing, we have Jipkin and Jaeger as well. So we have H2 server we're using as a relational database, MongoDB as an event store, and then we have Kafka for the event bus. And then we are using command bus with exon framework to support our distributed command as well. And then Jaeger has for tracing, and at the end we have case management service, which basically JBPM platform implemented for case definition. So let's do a little bit deep dive inside the onboarding microservices, what inside there. So let's zoom in a little bit more so we can see what is going on, whom it is communicating to. As you can see, for communicating with other microservice, it is using distributed command bus, and MongoDB as event store is to serve as a relational database, tracing, and then we have Kafka for event bus, and also have Jipkin as well. So if you notice on the onboarding, it is not talking to any other microservices, just via command bus. Let's log into the UI, and we're going to use the user called WBAdmin for this demo, and enter the password. Sign in, and you see the dashboard that shows some of the activities related to the tasks. So this is the party. It's showing the 2 status, onboarding or prospect. So prospect can be onboarded. So let's create a new prospect. We're going to put a number, put an ID, and this. Then we'll use first name. Then we're going to use last name, and we're going to change the status to prospect. And we save that. Let's go back and see that what happened to the data. So status is prospect, and you see that the event is there is party profile created event. So let's make some changes and see what is going on. So we're going to change the first name and we save it, and let's notice the event, what happens. So we can see that profile updated event as you can flowing through. Okay, so we're going to start the KYC with this and send this party for KYC. If I go back, you will see the status become changed to onboarding, and now and then start KYC button is gone because it's currently in onboarding status. So let's jump into KYC, see the detail part. On the top, you see the various stages coming from case management system, then party detail coming from party microservices, case detail coming from KYC services, and these milestones and roles are coming from case management, KYC events coming from KYC microservices. So there's a lot of microservices that are pushing the data in this UI. So let's take a look on the case diagram that shows where we are. So the flow is stitching the cases, and there's a subcase is onboarding also there, and currently we're in that subcase. Let's go jump detail onto the subcase of onboarding. And again, the similar way, but it's a different party coming from party microservices. We have initiation, and then similar fashion milestone as well. Then this is the case activity diagram showing various tasks as well. So let's take a look on the task, and we're going to be completing one of the tasks. So see how it looks like. So we're going to pretend that we're entering the data. Let's start, and then changes the status to in progress. We're entering the data. Let's finish it. Status is completed. So now, what is happening behind the scene? All this UI activity and microservice activity. Let's take a look behind the scene. What is going on? So I'm going to use Grafana with the Yagar, so to trace much more detail. Let's explore the problem Yagar detail. So we're going to pick up one of the microservices with a simple case, the KYC microservices, and as you can see, there's a lot of activities are captured. So we're going to use initiate KYC command for this part. Okay, let's run the query. And we have a trace ID. Let's go detail on that one. Let's close this left panel so we can see a little bit bigger and expand a little bit more. Okay. All right, so on the C, first part is command has been sent, and then the command has been handled, and then command emits events. As you can see, the event is there as well. If how we combine it together, so we are actually pushing every message a correlation ID, so group them together, and that's how we are tracking across the board. So this is a very simple one. Let's dive into a complex one. So how rest of the microservices are talking to each other. So we're going to use case start notification command to run the query and see how the microservices are interacting to each other. So there are two, so one for onboarding, one for KYC. We're going to pick the one that is KYC. The top one is going to be. So let's close the panel on the left side, and I'm going to move this one on the right and pull an architecture diagram. So that way we can actually go through the story, how the events are flowing through and properly. So I'm going to use a visual paradigm diagram. So the case management is basically submitting the event called case created, and that event is consumed by all microservices. As you can see, KYC microservices, onboarding microservices, and then our scanning microservices and approval microservices. Each of them has filter. Basically, if it is related to KYC, it will react to that, otherwise it will not. Or if it is onboarding, it will react to the onboarding. If it is scanned, then it will react to that part, right? So now on the right side, if you notice, you can see that this is a case start event, and because it is a KYC related, all the microservices, onboarding, approval, rest of them are not reacting, so basically they're filtering it out. However, KYC, because it is a KYC, it actually start working on that, and it initiated a KYC start command, and that command basically emitting two events, as you can see in this case, command emitting two events. So the command KYC command also consumed by the party microservices, and it's basically changing the status to onboarding from prospect to onboarding, and that's how it is reacting to that as well. So this is basically a choreography that you're seeing, and at the bottom is the event publication microservice, which actually consumes every event. There's no filter. As you can see, it is reacting to all of them as well. So and also finally, we can see that how they're grouping together. Same thing, every message we are utilizing using the correlation ID that we are pushing across the board. All right, so let's do a little bit more deep dive into our event store, how the event store is managed. We're going to use the Compass for browsing the MongoDB. Each of the microservices has their own event store, as you can see. So we'll pick one of them is the event store onboarding. Let's go a little bit more detail on that. So what's inside that to check the data inside the event store. Okay. So let's change the view. So you can see, as you can see, this is the event aggregate identifier and corresponding event get inserted. If you notice, there's a 0, 1 sequence number because event history is always insert only. And on the right, if you go a little bit more, there's also some versioning information. So that way, if payload version changes over time, so we should be able to track that as well using some sort of upcasting. We should be able to address that. So next, a little bit more, what's inside the data, right? So let's take a look. So we have the onboarding starting event, you can see, and then we have onboarding case file added event for the same aggregate identifier. However, the sequence number is different. As you can see, this is 0 and this is the 1. All right, so let's go back to relational database, how the query read database or read model is working, right? So we'll again use one of the microservice pickup and see how it is there. So this is the read model basically feeding the UI from here. So basically we're reacting. So this is the UI screen that you saw that shows the KYC, onboarding details information. So this is the data that is actually driving that. And you can basically see that what are the data available over here. Then we have a domain event entity. So for this microservices, what are the events that I'm interacting with or I'm responsible for? I'm capturing over here. So that is also pushed on the right side that you saw. So those are the onboarding events. We're also managing the commands in a service resilient way. So you can see the commands are here. This is captured. This time it is issued, and then also the content as well. So if microservice even failed, we should be able to replay that, and we have that framework does take care of that based on the status as well. It takes care of the replay or retry. Even if the service comes back online, it will take care of that. So next, we're going to go take a look on event bus. So I am using Kafka Drop as an UI for the Kafka. So if you notice, all the microservices has their own event topic. So we'll dive into one of the microservices. Again, we'll pick onboarding. There's only one partition. You can use multiple partitions as well. So let's explore one of the events. You can see the events with the header information that provides that what type of event as well, and tracking mechanism. And this is the onboarding case basically. So that's what it is showing. Okay, so next we will take a look into one of the microservices exposing the API. So this is the KYC command. So this is the state change of the system. So this is how these are the commands that it will react to, and these are the read models. So this is the query controller that takes care of the information that we need. And then we also have asynchronous communication management generalized into the framework as well. So this is the operation controller that takes care of a polling ID, and based on that, it will respond to you with a resource ID. So this is a Spring Cloud. So how does provided by Exon? So that is basically how microservices talk to each other without knowing who is where, right? And this is the Eureka with Spring Cloud, Exon framework, basically used as a combination for Spring Cloud. Okay, with that, so I have the demo. That's the total demo so far within for our part. So let me go back to the presentation. Okay. So what do we learn? What we have learned? Building software as a sequence of commands, events, and queries fell closer to the real domain. So our framework can accept DDD artifacts as natural input. Components are separated out easily as needed, scale up or down to achieve elasticity. Proper service isolation using boilerplate code out of the box, resiliency, and self-healing. We are able to follow solid patterns. And finally, asynchronous message passing between isolated, loosely coupled, location transparent components with service discovery. Things you would like to consider. So this is a different mindset, takes time, training to adjust and get used to. So lack of modeling tools. Consider to use event store if you are planning to event sourcing capability. So because it is just not persistent, it has much more capability exists on that. So with that, And these are the references that you see that we have, and a special thanks to our Wells Fargo colleagues, especially they spend a lot of time and their hard work to make this happen. So these are the references that I can provide as much as went through with the overall implementation. And again, thank you for listening overall. Any questions?
I don't see any questions, Tito, in the Q&A.
Okay. So let's wait, give folks, if anybody has any question, we'll address that. Otherwise,
we'll see you in the next session. Yeah. Thank you. How do you debug such complex microservices, Tito?
So yeah, that's a very good question, actually. So a couple of tools that we use, of course, the tracing itself, the event store itself covers a lot, and we have the command that we're tracking. So every information that I pass through, it has been tracked, and using the Grafana, you basically, or Yaga, you basically see where it is stopped, and you can basically take a look into which microservice is basically responsible for that. That's one part. Another part, there's a tool called ngrep. So because we're using this trace-based communication, so some of the cases, what data is in the OIR, you'll not be able to see that. So some cases, for example, the header and communication. So using the ngrep tool into those cases basically helped me a lot in terms of debugging as well.
Yeah, the other one was around tracking and managing the microservices. I think you speak a bit on that. I noticed, notice that all of the command and the information is stored, right? Like in the database as the transactions are moving. So as far as tracking, managing them, Tito, any other tools?
We have not yet introduced any other tools, of course, for the bank itself, right? So we capture all the logs and everything using our Elk stack, and also we have Splunk as well. So that's pretty much a lot of information covered.
Yeah, assigning the correlation ID in the Saga, that's probably the most important piece of information to tie that together, right, Tito?
Correct. Yeah. So the Saga portion is very much important. So fortunately, what happens, right? That's the biggest thing that we introduce, especially modifying or adding in our framework. So, and the good part is the exon framework provides the ability to tap into or intercept into messages. So what we did, we just intercepted the message and introduced that correlation ID in just few lines of code, and then using that correlation ID, we're able to track the entire thing. So again, we are tracking in pretty much our messages are command, event, and query. So whatever is request has been sent to us, it is stored into those tables itself. So you basically go and debug in the data straight out that what data is coming and what data is missing. I think I should be able to show that if it is available right now. So this is what I was talking about. So let me just jump into the part that is, we have the onboarding part I was showing. So whatever.
I was going to say, while you're at that, I don't think there's a particular choice on the event store for MongoDB. It was just something that was readily available, right, in our enterprise. Yeah. So it's pretty much it's just what was quickly available for us. Yeah.
So this is what I was talking about. Basically, every request comes up, we maintain the idempotency. We introduce the idempotency, right? So basically, every request is stored into this table to make sure that it is not duplicate check is there. So all the patterns that we showed in the boilerplate portion. For example, this is the command is coming. You want to debug on this command. So basically, this is persisted, and it is maintaining the content, basically what has been passed to. So you can basically see that, and then corresponding correlation ID as well. And if there's a process happens, we basically also capture those error messages, maintain the state. And also you have to remember that we got to do the parallel processing because multiple nodes is going to be processing these. So how do we address that? So you have to address that as well. And once this is done, this is the resource URL that we're passing back as an asynchronous communication. this status is maintained. So basically, error state or replay or whatever you'd like to do, you'd be able to do that based on your business name. So that's from a command point of view, and the correlation ID basically tied everywhere. So, and then event point of view, so of course, event store is your source for everything, and you also cover the events as well. So all the events are also covering, so you can literally see that what data content are coming over here, and based on that, you should be able to understand that, right, what is missing in the message itself. And other than that, from communication point of view, I use Engrave. Of course, that gives me a much more better information for quick debugging itself. Hopefully that answers your question.
I think so. The other one was the choices of technology, right? Kafka, the Kafka solution for the streaming instead of using Axon. It's another one where Kafka was readily available. I think we're still evaluating Axon server too.
Yes, we are. Yes, we are. Thank you, Javin. So we are actually evaluating, as I mentioned, right? So Event Store comes with this processing itself. It has like much more capabilities, not only persisting the event and streaming, right? There's also the routing, and some cases, right? Some of the cases, for our cases, Kafka, we can only store events in like 7 days or something like that based on our policy. So we need to store some way as well, right? So basically, our storage needs to be maintained. So, and then parallel processing of the events. So how do you do that? How do you handle that, right? So there are other capabilities. So based on that, based on our experience that we see, and that we had to do a lot of work around to address those. So once we're looking at Exon, just to make sure that we don't rewrite those code has been done, right? And take advantage of that.
Yeah. Yeah, I think that's probably something we'll be shifting to. Todd's question was needing to evaluate middleware and messaging and streaming solutions. I can say we're always constantly reevaluating the messaging, and so that's what the key. Really, the key part to this is to make sure you're abstracting, right, the particular technologies for what they're used for, because there's always newer, better, faster ones that come along down the road. So yes, I would say that's a constant thing that everyone will be doing, is reevaluating messaging and streaming solutions as they pop up in this space.
Yeah, I see there's a question from Nick as well about the performance boost.
Yeah,
yes,
performance.
we got serious performance boost definitely for sure.
Right? Yeah,
yes, that's light and day. So some cases we see like 24-second to millisecond range, right? So that's what we see because we broke down the functionality, and it performs pretty well. It's not that monolith problem. It was just over time the complexity grew bigger, and then performance was not that great as well. And that's one of the reasons, right? So we choose to break down this functionality.
Yep, the biggest thing is scalability too, right, Tito? I mean, we can scale this thing out, instead of having to get more RAM or more disk.
And the deployment. So the other parts, like every microservices, we do work on this part, right? So because our CQRS contract is pretty much stable, in this case, right? So every microservices independently operate and do their deployment without impacting anybody else. So that's the big one.
And I guess we'll do one last question from Alec. How do you troubleshoot the bottlenecks? Kiali, right? You're using Kiali and some graphical tools to be able to
Grafana
check it. Yeah, right. Grafana to be able to take a look at the latency, things like that. So, Tito, you want to explain a bit?
Sure. So yeah, sure. So as you can saw on the video itself, right? So when you using Yaga, right, it's actually basically the whole purpose of using Yaga or even Jeepkin, right? So distributed testing to see what is the timing looks like and what is the bottleneck is, right? So that's the beauty with the distributed tracing. And you want to use the distributed tracing because of that, and it will show you where it is stopped, right? Especially using the correlation ID is going to tell you that at what part things are broken. So you basically readily jump into starting from that point to start debugging over there. And it shows you the timing wise, right? If there is an issue going on, so you basically take a look on that timing, corresponding services, why it takes time, and take it from there.
And Nick's last question was, did we break down every single service that we have, or are some still running? No, we use the strangler, so only a few of the services are running. Not every service is broken down.
It's
So
still moving things,
yeah.
yes.
So this is still moving. So as we strangle more and more on the monolith side, the case manager, all the logic that was built into the BPM or some of the Java processes there, we'll slowly integrate those into this framework. And that's why we really needed something that all the developers could follow so that we could have a huge development force, working on migrating this functionality. So good question. Yeah. All right. It's definitely top of the hour. We were 5 minutes over. So thank you again. And we'll see you at the summit.
All right. Thank you very much.